Hello, I am the Bio Guy, and in this video we'll count down 5 diseases that scared the bejesus out of me from the first moment I heard of them. If you like videos like this and you'd like to see more, please do me a favor and like and subscribe. And if you'd like to learn more about any of these diseases, add a comment below in the comments and I'll make a video dedicated to it. Okay, here we go. This entire list could have been populated exclusively by transmissible spongiform encephalopathies, TSEs. But I chose one, fatal insomnia, to represent the group, as for me, it's the most terrifying. Fatal insomnia is an encephalopathy, that is, a brain disease, and it's characterized by the failure to sleep. If you ever had really bad insomnia, you know how frustrating and physically uncomfortable it can be. Imagine that being your reality for years, potentially. Sleep, especially deep sleep, serves the extremely important function of allowing the brain to flush out toxic byproducts of metabolism. While fatal insomnia was formally defined in 1986, a case described in 18th century Italy was very likely fatal insomnia. Historically and today, the disease is exceedingly rare, with only hundreds of cases being documented. The patient will first notice increasing insomnia leading to progressively worsening psychological impairments, including paranoia and hallucinations. The insomnia becomes complete, and massive weight loss and dementia precede death. There is no available treatment. Human TSEs originally result from mutations in the gene PRNP, which encodes the prion protein PRP. The PRP protein is primarily expressed in nervous tissues and has a real physiological function. But mutations in PRNP that result in specific incorrect amino acids at positions 129 and 178 of the PRP protein cause that protein to become a prion, a molecular zombie. Prions are oddly shaped compared to the wild-type PRP, are hyperstable, can convert wild-type PRP to the prion shape, and are lethal. The mutations can be inherited, causing familial fatal insomnia, FFI, which runs in about 70 families globally. The disease can also arise spontaneously without the associated mutations. This is known as sporadic fatal insomnia, SFI. Fewer than 50 cases of SFI have been documented. So why is this called a transmissible spongiform encephalopathy? Well, imagine a fatal insomnia patient were to undergo surgery. The prions would contaminate the surgical tools and equipment, and what makes prions so terrifying is that they are hyperstable. Prions laugh at the usual and otherwise highly successful sterilization techniques. If the fatal insomnia of the surgical patient is unknown, the surgical tools and equipment will be sterilized and used again, but the prions will still be there, and the next surgical patient can be infected. Thankfully, TSEs are extremely rare, so the chance of this happening is vanishingly small. Now, there is no short supply of scary viruses. Ebola, HIV, rabies, for example, but these are all well known. A less well-known virus that is probably more frightening in its potential than its already pucker-inducing current reality is Nipah virus. Nipah virus infection is one that gets healthcare providers wearing the white Tyvek hazmat suits and wondering if they're being adequately paid. While infection with Nipah virus can lead to a myriad of outcomes, even including asymptomatic infection, it is notorious for its ability to cause severe and fatal encephalitis. Simply put, a swelling of the brain. Outbreaks of Nipah virus disease have a case fatality rate, CFR, of between 45 and 75%. Fatal cases begin 4 to 21 days after infection with headaches and muscle soreness. This proceeds to uncontrolled muscular contractions, jerkiness, limb weakness, coma, and finally death. There is no known treatment effective against Nipah virus. Let's pause for a moment so we can be clear about what the case fatality rate, CFR, is and what it truly represents. It is a measure of the severity of the disease, not the virus per se. Mathematically, it is the percentage of individuals diagnosed with the disease that die from the disease. That is, deaths over diagnoses multiplied by 100. This is not to be confused with the infection fatality rate, IFR. IFR is a property of the infectious agent. With Nipah and other infectious diseases, people can have no symptoms, that is, no disease. Thus, the denominator in the IFR equation, the number of people infected, is a little fuzzy. The estimates of how many people are infected, and thus the IFR itself, has the potential to be highly inaccurate. By contrast, CFR is a hard number. The number of people who died of the disease and the number of people who are diagnosed are reasonably well known. Therefore, CFR is used much more commonly than IFR. Back to Nipah virus. Now, Nipah virus disease occurs in outbreaks, and these have occurred in Singapore, Bangladesh, India, Malaysia, and the Philippines. It was first identified by the Nipah River in Malaysia. Of 283 cases in that initial outbreak, 109 passed away. Many outbreaks have followed. The following is just a fraction of them. India, 2001, 45 deaths from 66 cases. 2017, 17 deaths from 18 cases. Bangladesh, 2004, 27 deaths from 36 cases. 2023, 8 deaths from 10 confirmed cases. The Philippines, 2014, 14 deaths of 17 cases. At present, outbreaks are occurring in India and Bangladesh. So how are people infected with Nipah virus? Well, there are many ways, and it all starts with bats. Terapus bats, the flying foxes, are the reservoir for the Nipah virus. That basically means that the virus is ever present in the bat community and can be transmitted to humans either directly or indirectly. It is a zoonosis, or a zoonotic disease, a disease that is transmitted from animals to humans. In Bangladesh, many infections are the result of sap harvesting, as infected bats can contaminate the open pails of sap with urine and feces. People can also be infected through the saliva and fluids of infected dogs, cows, pigs, and other animals. Nipah gives me chills because it is also transmissible from human to human via close contact and respiratory droplets. While there is no evidence of aerosol spread, it is still much easier to transmit from person to person than something like HIV. So will we get a pandemic of Nipah virus? In short, it's unlikely. To explain in an epidemiological way, the basic reproductive number, R0, is below 1. That means in a naive, non-immune, and non-resistant population, when the virus enters the population, each infected person will, on average, infect less than one other person. So the outbreaks eventually die out on their own. Now, the basic reproduction number is a property of the virus, and if it mutates, well, let's keep an eye on Nipah virus. It's one of frightening potential. You may not have heard of subacute sclerosing panencephalitis, but it is a result of a viral infection that is becoming more common, most notably in the United States. The virus is the most contagious of all viruses, with estimates of R0 between 12 and 18. It is, of course, measles. Now, primary measles infection is a serious matter on its own, causing a potentially fatal disease. But subacute sclerosing panencephalitis, SSPE, which can follow a measles infection, albeit rarely, has a CFR approaching 100%. SSPE usually follows the clinical resolution of measles by 7 to 10 years, but onset can range from a couple of months to almost 3 decades after primary measles. The disease is subdivided into 4 stages and would manifest itself by personality changes, fever, and headache as the swelling brain pushes against the immovable wall of the cranium. The disease will progress to muscle spasms, uncontrolled jerkiness of the limbs, dementia, blindness, paralysis, coma, and death. What causes SSPE is the measles virus itself. Current estimates are that as many as 1 in 600 children under the age of 5 who recover from measles will develop SSPE. When we look at the classic symptoms of measles, especially the rash, we forget that measles virus can reach the brain through infected immune cells and infect nervous tissue. If the virus persists in the brain, it can continue to slowly replicate, which means it will accumulate mutations. While the exact pathophysiology remains uncertain, it appears that mutations in the measles fusion protein gene and the matrix protein gene correlate with SSPE. Protein inclusions, which are aggregates of protein within cells, are observed in neurons, and indeed, these were the histological hallmark observed by James Dawson when he first identified SSPE in 1933. While this is a scary disease, it is almost 100% preventable through the MMR vaccine. But if you don't vaccinate your children with MMR, you really have to worry about your child getting measles. And if your child does get measles, you have to worry that your child might not survive measles. If your child does recover, then you have to wait up to 30 years wondering if your child will die the horrible death of SSPE. The incidence of SSPE is low, but the disease is becoming more common due to the fraud of Andrew Wakefield, celebrity anti-vaxxers, the modern anti-vax movement that followed COVID, and misinformed government figures. I was in 7th grade, and Mrs. Coverley, our much-loved and admired history teacher, was telling us of a drive she took in an open Jeep in the plains of Africa. She said she pointed to the windscreen and yelled, "Tsetse fly," which was immediately killed by her guide and driver. As we sat safe in our classroom in the United States, we were still chilled by this anecdote. We had heard of African sleeping sickness, and even though we were an ocean away from it, it scared the crap out of us. African sleeping sickness, or human African trypanosomiasis, has a case fatality rate of over 99% if untreated. As kids, all we knew is that you got bitten by a tsetse fly, you fell asleep, and you never woke up. The disease follows the bite of the tsetse fly infected with either of two species of trypanosomes. The first of two stages is the hemolymphatic stage, when the trypanosomes are in the blood and the lymph. This occurs 1 to 3 weeks after the bite, and the patient will likely have a sore at the bite site, headache, sore muscles, loss of appetite, and intermittent fever. For Trypanosoma brucei rhodesiense infection, this stage will last 3 to 9 weeks. If the parasite is Trypanosoma brucei gambiense, the stage will last 10 to 18 months. As this stage is much easier to treat, it is vital that it be correctly diagnosed. Insidiously, the symptoms could look different in non-African travelers to endemic locations. The second stage, the neurologic or meningoencephalitic phase, begins when the trypanosomes cross the blood-brain barrier. The patient could experience tremor, muscle weakness, paralysis on one side of the body, lack of feeling, and of course, disruptions in the sleep-wake cycle. Interestingly, the parasite has the ability to influence clock genes in the central and peripheral nervous tissue, giving rise to the disease's nickname, African sleeping sickness. Ultimately, the patient will fall into coma and pass away. The disease can be treated with sermon, but sermon does not cross the blood-brain barrier and thus must be used before the onset of the meningoencephalitic phase. Interventions used to treat the second neurologic phase carry toxicity risks and are rarely successful. It's 1831 Massachusetts, and the horses are acting oddly and dying of a disease that would come to be known 100 years later as Eastern equine encephalitis. Despite its longevity, the disease remains rare in humans and was relatively unknown to the average person living in the Northeast until 2019. That's when 12 cases were diagnosed in Massachusetts and 6 people died. I was in the lab at the time, and I heard some of my students talking about Triple E, as the disease is colloquially known. The reference to the disease gave me chills. The 2019 outbreak was generally typical of Triple E. It occurred in the summer, was localized to an area near a hardwood swamp, and disappeared. It was particularly aggressive, however, with a case fatality rate of 50%, which is close to the high end for Triple E. Triple E is another encephalitis, and the symptoms are those that commonly result from a swelling brain in a non-expanding cranium. The soaring intracranial pressure causes headaches, behavioral changes, spastic movement, seizures, and more. There is no treatment for Triple E. There are a couple of vaccines to prevent Triple E, but one is for horses and the other is for high-risk laboratory personnel. Triple E is caused by the Eastern equine encephalitis virus, which I'll call Triple EV. What is scary about this virus is that it's transmitted by mosquitoes. 21 different species have been shown to support the replication of EV, but we got lucky in the species of mosquito that carries the majority of the virus. That species is Culiceta melanura, and it lives in hardwood swamps and has a greater taste for birds than for humans. But as the human populations are growing, housing is being pushed out to remote and less habitable areas like hardwood swamps. This is only part of the explanation as to why outbreaks of triple E, while still very rare, are increasing in frequency. So where does triple EV hide out while it's not infecting humans? The reservoir for the virus is passerine birds, songbirds. The mosquito Culiceta melanura serves as the enzootic vector. That means that the mosquito shuttles the virus within animal populations, specifically the birds. The combination of the birds and the mosquitoes keeps a population of virus in the birds. So, how do humans get infected? Well, these mosquitoes will occasionally bite humans if they have the opportunity. The people that will be bitten either live near or are exploring visiting hardwood swamps. But there are also so-called bridge vectors, species of mosquitoes that are less picky in their diets and are more likely to transfer triple EV from birds to humans. Now, what would happen if a city person were to be infected and return home to the city? Could the city mosquitoes transfer the virus to other humans? Thankfully, the answer is no. Humans, as well as horses, are dead-end hosts. While we will continue to see outbreaks of triple E near swamps, it should not spread to cities, as is the case for diseases like Ebola. And now you see what universally scares me: brain infections, as all 5 of our little-known diseases involve severe and potentially fatal brain infections. The brain is the master controller, and when it is diseased, the symptoms can be broad and devastating. These diseases take control and rob patients of dignity and death, and that's why I find them so frightening. Now, this video is for informative and entertainment purposes alone. Nothing in this video should be or can be taken as medical advice. Medical decisions can only be made between the patient, his or her caregiver, and trained medical professionals. If you believe you have an illness, seek care from a trained medical professional.